like x cubed. X cubed, the first derivative equals 0 at 0, but that's not a min or max. The second derivative also equals 0 at 0, and that's an inflection point. It does change concavity. X cubed does, from this to this. But the first derivative also equals 0. That's why it's a candidate. But you need, just like for an inflection point, you need the change in concavity. For a, yes?
Wait, so it's okay if we say that the 2 points are like x equals 1 and x equals 1, and we say that it can't be x equals 1 because it's increasing throughout, and
Yeah.
it is x equals 2 because it's changing?
Yeah, if you said it, so that's a, like I like you even said the candidates, but then we answered the question. You said this cannot be and this can be. So that'd be great. You get the full points by recognizing x equals 2 is good, and it sounds like your justification was good as well. Okay, guys?
No, I didn't mean x equals 1. I meant like at 0 though, because isn't that?
Oh,
isn't
at
that
0?
endpoint? It's actually included. It's close 0.
I wonder if they would do it
open
that
4.
Let me see. That's a really good question. According to this grading rubric, like you would be, because you have the value.
It's the lowest given. It's an included point.
Yeah. I think if you said 0, I'm sorry, you said 0. I thought you were saying 1.
0 and 2, but yeah.
I would give you both points. I'll put it on the list here to see what everyone else says, but I mean that's a good point because that's an endpoint. You do have the point. Let's see. Yeah, it says on the interval 0 to 4. Okay. Yeah. That's interesting. Good call. And then B, I saw a lot of nice shark fins yesterday, and you got 2 points. One for just because you have the values, you have like the 4 points, and it says and the behavior at 2, 2, so that weird little shark fin. And then the other point was for the rest of the increasing, decreasing, and concavity. Okay, so another 2 points for that. So a lot of good points on there. All right, 5. 5, we were doing B and D on this one, right? So you have this nice pretty picture. It's a car traveling. What are we looking at? What graph is this? It's a velocity versus time graph. Always tell yourself that first. This is could be a derivative or however you want to say it. So it's a bunch of line segments too. So you can do a lot of things with lines in terms of derivative. B asks, what is V prime of 4? And how can you do that? What happens at 4? What would be the derivative at 4? Yes, it doesn't exist because the derivative from the left does not equal the derivative from the right. And that's what they're saying in their big explanation there. You see the limit as x approaches 4 from the left of that rate of change. You see that? But if you say the derivative from the left does not equal the derivative from the right, you can put some values in if you want. The V prime of 4 does not exist. I mean, I would say add something about the derivative from the left and the right. You know, you should need that full limit of the rate of change. But if you, as long as you say the derivative from the left and derivative from the right, I would add. You know, anytime you can add just that little bit of calculus, you're being safe. You know what I'm saying? Same corner, maybe. You know.
You couldn't do ideas equally.
Is that what you wrote?
Yeah.
Okay. Anytime, I would add anything like where it doesn't exist. Say something about the left and the right. Like say the values like just like you would a limit, like the limit from the left equals the limit from the right. So the limit exists somewhere. Same thing with the derivative. And then let's see for the second one, v prime of 20 is just a line. So you just literally find the slope on the line. And I would add, you guys, anytime you have the chance, like I would just kind of do it in your head, even though it looks like that's what they'd give it to you. They'll give it to you if you just got the value. That's kind of shown to me. But you see how this is still calculus? This is the difference quotient. You know what I'm saying, guys? So this is still calculus. This y2 minus y1 over x2 minus x1, even though it's a line, will give you this value. And then check this out. One whole other point for the unit. The unit is a whole multiple choice question. The units. Did you guys put the unit? Good. You know what I'm saying? Like, and you're not going to know. Put those units every chance you can. All right, and D, let's say find the average rate of change. Does the mean value, so the average rate of change on 820, again, you just take those values and you get some answer. Make sure you put a unit on it. And then does the mean value theorem guarantee at one point that it'll equal that value? No. Why, Katie? Why no? Not mean value theorem does not apply in that graph.
Because there's 2 quarters.
Yeah, because it's not differentiable on the open interval. It has to be continuous on the closed, differentiable on the open. Since it's not, it just can't guarantee that that happens. Okay? Is that the last one then? Okay, great. So here's what I want you guys to do. I'm going to give back out those multiple choice packets. I want you guys to check it.